Hello everyone. So in this video I will do a few examples in chapter 2, motion in 1D. So let's start with the first example, which is homework problem 2.5 on your textbook. And we try to um, have a better understanding of uh, the difference between average velocity and what is average speed. So in this one it says you start moving from a front door, so you start moving from a house here and you move 60 meters to a windmill. Okay, a windmill, let's see, it would look something like this, 6 meters. And then you turn around, you move 40 meters to a bench where you sit over there and watch the sunrise. So it takes you 28 seconds to walk from the front door to the windmill, and it takes you 36 seconds to walk from the windmill to the bench. So what would be the average velocity for this motion? And the thing we need to understand for this one is what's the definition of average velocity? Then the definition of average velocity is displacement over time. And displacement is your final position subtract your initial position. So here this is your initial position and this is your final position. And from what's given by the problem, you walk east and then turn around, walk west. Your displacement in this problem is 20 meters. So your average velocity is 20 meters divided the total time, which is 28 plus 36. And you put in all the numbers, you get 0.313 meters per second is your average velocity. So we do the same thing. We want to find out what's the average speed for this motion. Average speed, then for average speed you need to the distance traveled divided by delta t to find out the average speed. So if you look at this, what's your distance traveled? First you travel 60 meters and then you travel 40 meters. So your distance actually is 100 meters. And the total time doesn't change, it's here. 28 plus 36 give you 64 seconds. So your average velocity is 1.56 meters per second. Okay, I hope this example gives us a better understanding what is the definition of average velocity and what is average speed. Now we go to example 2. Want to calculate. It gives us the velocity of a car as a function of t. alpha beta is constant given alpha is 3 meter per second, beta is 0.1 meter per second cubed. Now I want to find out what's the average acceleration from time t equals 0 to t equals 5 seconds. What's the definition of average velocity? Is displacement over time, right? Average velocity. What is definition of average acceleration? Is change of velocity over the time it takes. So which means we need to find out what's the velocity of the object at t equals 5 seconds, subtract what's the velocity of the object at t equals 0 seconds, divide by the time it takes, which is 5 seconds, of course. Basically, we need to find out the v at t equals 5, which becomes simple problem. Just replace t by 5. So 5 times beta gave you 0.5, alpha is 3. Okay, so we got, actually this is 0.1 times 5 square, right? 25. So it'd be 3 plus 2.5, 5.5 meter per second. That's velocity at t equals 5 seconds. And then we find t equals 0 seconds. Then t equals 0, 3 meter per second. So change of velocity is 2.5. And time is 5 meter per second square. So average acceleration is 0.5 meter per second square. Calculate the instantaneous acceleration. Now if you want to find out instantaneous acceleration, it is a different approach compared to problem A. What we need to do, we can find out what is ax function of t by doing one derivative of v as a function of t, and it should give us 2 beta t. So ax t equals 0, you replace t by 0, I got 0 meter per second square. T equals 5 seconds, replace t by 5, is 1 meter per second square. Okay. So usually you might get a very similar problem compared to this one on your exam 1. So this what it gives here is giving us velocity as a function of time. So I might give you position as a function of time and ask you for average velocity and instantaneous velocity. So try to review the example I gave during the class for a better understanding of how to calculate those kind of quantities. Now this is to the velocity as a function of time. So velocity, you can see velocity is second order in t, so it's a parabola curve, and then you do one derivative, it becomes linear, so you have a constant acceleration. Example 3 is a constant acceleration motion problem. We said for all constant acceleration problem, you need to identify what are the 3 quantities that are given and what's the quantity that is asking. So you have 4 variables. You pick the kinematic equation that has those 4 variables and use 3 known quantity to solve the unknown. That's all the game plan. So let's look at this one. So the ball left the racket, this velocity start from rest. So we have 2, right? You have V0 is 0 meter per second. You have final velocity and you have T converted to SI unit. Okay. And it asks what's the ball's acceleration? A. So you need to check those 5 equations, which one has these 4 variables. Initial velocity, final velocity, T, acceleration. So I think this one has, which is the first one. I think the first one has everything, right? Final velocity equals initial velocity plus AT. Then you solve for your A. Final velocity subtract the initial velocity divide by the time. Plug in all the numbers, you find the acceleration is a large number. Okay, B. How far the ball traveled during the serve? Okay, we have this, and then it asks us for displacement basically. So we want to find a equation. Has these 4 equations. Let me see which one. I think if you check those 5 equations, you'll find the second one have these 4 variables, right? So you can have that x equals 1/2 initial velocity plus final velocity times t. Plug in all the numbers. Finally, displacement is 1.1, which is basically the length of the arm of the tennis player, which is reasonable, right? Okay, now another example in constant acceleration motion. So the maximum acceleration we can endure is 250 meters per second square. Now if there is accident, initial speed given 65 miles per hour, and we stop by airbag, we want to find out what's the displacement basically. So check what do we have. We have acceleration 250 meters per second square. We have initial velocity. Let's convert it to SI unit. If you convert to SI unit, it gives us 29.17 meters per second. Final velocity, right? Stopped. So final velocity has to be 0. Those are the 3 known quantities. And we need to find out what is displacement. We need to find the equation has its 4 variables. If you check those 5 equations, you find that the 5th one has everything. And you can solve for theta x now. So let's stop distance, the minimal stop distance for this car accident. And of course, we hope nobody get a car accident. Okay, now the last example for today. We have a brick drop from a very tall building. 0 initial speed, strike the ground, (1.9 seconds). Initial speed, time, we got two variables, right? And we said that we need three variables for all constant acceleration motion. Now this one was the third variable, think. You drop something from the top building, and then what's the acceleration? It got to be negative 9.8 meter per second square. It's always pointing down, right? This is your acceleration for the problem. So now I found the three known quantities. So we need to solve the unknown. First, distance or height of the building basically need displacement. So you have initial velocity ta, you want to solve displacement. I would use a third kinematic equation, right? V0 yt plus 1/2 a t squared. Now, of course, your V0y is 0. You plug in everything, you find your displacement is 17.7 meter negative. The displacement is 17.7 meter negative. And the height of the building, of course, is going to be 17.7 meter positive. What's the magnitude of Briggs velocity just before it reaches the ground? Here. So basically, it's final velocity. So you have initial velocity ta, you want to find the final velocity, you're going to use the first kinematic equation, final velocity equals initial velocity plus at, plug in all the numbers, 18.6 meter per second, that's the final velocity of the brake here. And of course, it has to be negative, because your A is negative, so your V1 is pointing in the down direction, which is a negative y direction. So for the free fall, as I said, I usually would suggest we choose up to be positive and down to be negative. Now if we plot the magnitude, of the all the quantities for motion, acceleration 9.8, always a constant, so velocity becomes linear, straight line, and slope is, the slope is 9.8 meter per second squared. Slope of velocity versus t give you acceleration. And then the magnitude of the displacement becomes a quadratic equation.